In this lesson, we discuss different block cipher modes of operation, dealing with different operation environment or requirement. A mode of operations describe how repeatedly to apply a cipher single block operation securely to transform the amount of data larger than just a block. IV is defined to be initialization vectors. Most of cipher mode of operation require a unique binary sequence, often called an initialization vector, for each encryption operation. They need to be random and non-repeating. It ensures different ciphertexts that generated even though with the same plaintext appear differently, different at multiple times, that could appear multiple times in the messages. The simplest encryption mode is ECB, Electronic Code Book mode. In this case, in this mode, no IV initial vector is used. Every plaintext block is encrypted with the same key, will produce the same ciphertext. And with this kind of ciphertext, same ciphertext appear for same plaintext with the same key, could be used or guessed by the attacker and susceptible to block swapping attack. Ursum, Mail, Smith, and Tuckman invented the cipher block chaining mode, CBC mode, of operation in 1976. Every plaintext box in their design is exclusive or with initial vector first. The ciphertext is used as IV for the next block. For encryption, each block needs to wait for the initial vector from previous block to be encryption to be generated. And therefore, the encryption cannot be parallelized. They have to wait one at a time in a sequential manner. Since the IV is the previous ciphertext blocks, which typically receive before the current block on the receiving side, no computation is required in terms of decryption. For getting the IV, you can do random read, so long as the previous cipher block is also read. Let's consider the situation where the bit can be garbled in transmission. What happens if a bit got garbled during the transmission? How many blocks of the receiving block will not be decrypted correctly? Say one bit in the cipher block 0 is not correctly received. The plain box 0 and the block number 1, plain box number 1, will not be corrected. Since C0, the cipher block 0 is also used as an initial vector for the second block decryption. And therefore, altogether, 2 blocks are affected. And there are techniques that other modes try to reduce this. Here we show the famous example, the original Linux logo image is encrypted using the AES ECB mode. Since there are so many image blocks in the original message that has the same pixel values, the encrypted blocks also have the same cipher values. When the encrypted image is displayed on, we can see the contour and the same color region are shown, even though there's not exactly the same color values. The encrypted image on the right mode, on the other hand, we use other mode, and you can not even see any information in terms of contour and the shape of the image. For terminal type application, waiting for a character before sending the ciphertext is not an option. We like to see character send and receive right away for better response time. In Cipher feedback mode, we use ship register and set it to some initial pattern, initial vector. For example, its value is encrypted with a key, and the leftmost byte is exclusive with the first byte of the plain text, or the first byte of the ciphertext. Send it right away, immediately out to the receiver. The cipher characters are also shipped in to the ship register from the right. And this process will go on for each characters. And what is shown in the picture is how the 10th character is encrypted and put it back to the ship register. The right side is the equivalent decryption process. Note that the same encryption box is used, not the decryption box. Since each cipher character needs to wait for the previous ship register encryption result, the characters cannot be encrypted in parallel. Has to be done in sequential manner. For decryption side, once you receive enough previous ciphertext character to fill in the ship register, you can start do the decryption process. Therefore, decryption can be parallelized. So is the random read access. In output feedback mode, or so-called string cipher mode, the key string, a sequence of bits called key string, is generated only with the IV and the key. And that string is then exclusive all with the plain text. Therefore, early ciphertext or cipher bit does not involve with the later encryption. With this isolation effects, one bit transmission error only result in one bit in the plain text error, not gobble the whole block. It is much better than the previous mode where the whole block is gobbled. So when dealing with unreliable kind of transmission. However, since the key string pattern is depend on the previous block, IV, so IV after IV, therefore it cannot be parallelized, both in encryption and decryptions. Yeah, we need to wait for the key string to generate one at a time. And there's a feedback loop there. And it also cannot provide random read access. Counter mode is designed to make both encryption and decryption process can be done in parallel. So performance is a requirement and a priority here. Here, the initialization vector of the block N is very straightforwardly compute without having to wait for previous IV. It's IV plus N, simple N. Here we show how the cipher mode or operation are used in tools such as OpenSSL to specify the actual encryption and decryption operation. In OpenSSL utility command, the cipher type option, you can use --help to generate that. And the cipher type operation is specified by first the encryption standard, followed by the key size number, followed by the short name of the cipher mode operation we discussed in the previous lesson. For example, AES 256-bit key with cipher block chaining mode is specified as dash as an option, AES-A256-CBC. CBC is a short name for cipher block chaining mode. The last command show in this view graph show how a plain text file is encrypted in this cipher type and saved in base64 mode using base64 as an option as output file ciphertext.txt. Note that there are other modes such as GCM and XTS. GCM is a new mode approved by the NIST. GCM stands for Galil's counter mode. It combines the counter mode encryption with authentication operation. So in the same method or operation, both encryption and authentication can be done. The encrypted text is then contain the IV, initial vector, ciphertext, and authentication code. XTS, on the other hand, is used in disk encryptions and is considered to be de facto standard.